All right, so we're on to combining like terms and distributive property in this video. So essentially, we're just going to walk through some examples together. We're going to talk about what makes something like terms, give you some terminology, and then I'm going to get into doing some distributive property, in which then after distributive property is done, I'm going to put a couple of distributive properties together, and then we're going to have to combine like terms. And that's the goal of this video, is to be able to simply do a couple operations with some stuff and then combine like terms. So let's get into it. So first things first, we're going to talk about some terminology here. And the first piece of terminology that we need to speak about here is going to be, what do I call the parts of an expression? And the parts of an expression, it's pretty simple. So parts that have a letter, okay, with a number, or just have a letter, right? They're called variable terms. So if I look at this expression that says 7x plus 3 minus 5x plus 8 plus 4x minus 1, okay, what I notice here is that some of these things have a variable and some of these things do not. So the things that have a variable, okay, are things like 7x. And then the other thing that has a variable is this negative 5x. And please note that I am including the sign that is in front of these things. So if you look in front of the 5 here that's in the expression, I am including the negative that's in front of it. So that's an important piece. The next thing I have is this 4x. So comma 4x. So these are all my variable terms. And then I have constant terms, which are terms without a variable. So they're called constants, right? Because we talked about the reflexive property, where A equals A, which means a number must always be itself. So it's called a constant because if a number continues to always be itself, that's kind of the definition of being constant. So your constants are 3, 8, and negative 1. The last thing we want to talk about is the number that is in front of or next to the variable. So in the variable term, what is the number that is in front? Okay, it's not behind it. It's very important you understand it's in front of the variable. Okay, is called the coefficient. So the coefficients up here are 7, negative 5, and 4. Now, those numbers are important in the terms of the variable term because those are the numbers that we're actually going to be doing our math with, okay? So when you have variable terms, all right, that we want to bring together all into one pile, okay, we do the math with the coefficient. Constants, we can just add them as is, looking at them and looking at what they are. So with that being said, let's talk about this idea of common terms. It's called combining like terms. And then what we're going to do, okay, is we're going to come with an answer. So there's a couple things we need to talk about. Okay, and the thing we need to talk about before is this idea that I was just mentioning called the reflexive property. So the reflexive property states that a number is always itself. So once I claim an x, or I write x on the board, okay, it doesn't matter if I put a number in front of it, but once I write an x, okay, it doesn't matter what I have, so I had a 7x. What's important about that x is that x is always equal to x. So that means wherever I see an x, it must be the same x as the one I wrote before. And that's an important piece because that's what combining like terms is enabling us to do. It enables us to all right, bring things together. So if x is always so with that being stated, right, wherever I see an x must be the same x. So the reason I'm bringing that up to you here is because if we go back to the top here and we take a look at those x's, okay, this x, okay, must be the same as this x, which must be the same as this x, right? And the reason I say that to you is because if those are all the same x and they're all the same thing, well, then I can compute how many of those x's I have, and I've got 7 in the first group. Then I got to take away 5, and then I get an additional 4. So 7 take away 5, okay, with an additional 4. So again, I'm doing the math with the coefficient. So 7 take away 5, add 4. So 7 take away 5, add 4. So 7 take away 5, add 4 is 6. So that means in this expression, which I have now written down here as well, okay, that 7 x's take away 5 x's and add 4 more of those x's gives me a grand total of 6 of those x's. And then thereafter that, right, we go into these constant terms. And the constant terms are just the numbers that we can put together because order of operations allows us to take numbers and add or subtract them. So I have 3 plus 8 minus 1. 3 plus 8 minus 1 is 10. So my expression is 6x plus 10. Now, why can't I combine 6x plus 10? Well, because x's are x's and 10s are not, right? 10s are a number. So this is always going to remain 10, all right? And this right here is going to be 6x. So the x's can't be combined with constants, okay? So you cannot combine a constant with a variable when adding or subtracting. So again, what's important that I just said to you, you cannot combine a constant with a variable when adding or subtracting. We can do it other times, but adding and subtracting is not one of them. So we got some examples down here that I'm just going to quickly go through. I'm going to go through, a couple on this page, before we get into something else here. So here we go. On this page, what you'll notice is pretty much all the variables are, one type of variable. So if you take a look at number 1, okay, we start off with 3x plus 6x. Well, then they're alike because they are x's. So the math we do is 3 plus 6. So 3 plus 6 means 9x, okay? Jumping around, I'll jump down around to, let me jump to 5. So I'll do 5. All right, so number 5 says 7p minus 1 minus 9p plus 5. So what I'm noticing here, right, is if I want to rearrange this, it's more than welcome to do so. So if I take a look at my variables, so I have a 7p, I have a negative 9p, so that's my variable terms, and then I have a negative 1 and a positive 5. So I'm just putting a comma there, right? Because basically I want to know if I can combine them. Well, these two are of the same variable. So I can do 7p take away 9p, and then the constants I can also do. Now, the way that teachers generally will show this is generally they'll get you to take out a highlighter or whatever it may do, and they'll tell you to highlight the common terms, so 7p and negative 9p. Just make sure you're including the sign that is in front of the number. Very big common mistake is people just like to use the number. They don't like to use the operation that is in front. Okay, so that's an important thing. So here we go. 7p minus 9p is negative 2p. And then negative 1 plus 5 is positive 4. And then the last one I'm going to do is I'm going to do 7. Okay, so in number 7, notice we have x's and y's. Well, when you do this, right, what's important here, okay, is that an x is an x and a y is a y, right? We don't have anything here linking saying that x's and y's are equal to one another. So because we don't have anything here that is claiming equality amongst the x's and the y's, what I'm going to have to do is I'm going to have to keep my tally of x's separate from my tally of my y's. So when I do that, I'm going to go through and I'm going to highlight, okay, my x's. So my x's are 5x, negative 1x, and then a positive 3x. And then I'll highlight my y's, which are positive 7y and positive 2y. And then what I can do is the math with the coefficients in blue. So the coefficients in blue are 5 minus 1 plus 3, and 5 minus 1 plus 3 is 7. So this is 7x. And then I can do the math with the coefficients in red, because those are the y's, and that is a positive 7 plus 2, which is a positive 9y. So the final answer to this one is 7x plus 9y. All right, so let's take a look at now some problems that have exponents. And with exponents, what you need to know, okay, is this, right? So you need to go back to the reflexive property. And the reflexive property is an important property for us because it determines things that we can do. So here's the deal, okay? In the first problem, in number 9 here, it has an x squared. Well, x squared is equal to x squared, right? Reflexive property states when you put something down, it is itself. So I have 5x squared and 7x squared. So the question is great. Well, how many x squareds do I have? Well, the amount of x squareds that I have then are using the coefficient is 5 plus 7, which gives me 12x squared, okay? Now, I'm going to jump down. I'm going to jump around here for a little bit, but I'm going to jump down here to number 12, okay? And in number 12, okay, it's got k squared and it has some k's. So this means reflexive property is k squareds are equal to k squareds. So k squareds are themselves. And also you need to know that k's are themselves. So that's an important distinction. All right. K squared is not the same thing as a k. So k squareds are equal to themselves and k's are equal to themselves, right? By reflexive property, a number is always itself. So what that means is you cannot combine, even though that the variable is of the same letter, okay? We can't combine them because they aren't equivalent to each other. A k is not the same as a k squared. So what this means is that when I go through this problem, I can combine the k squareds here, and then I can combine my k's, okay? So I put 2 lines. So if you're using a pencil, one common thing is to put the amount of lines as the variable has, right? So, or the largest. So this is a k squared. If you have a highlighter, great. Let's use a highlighter. So I've got my k squareds belong together. And then in green, I'll highlight my regular k's. All right. And then last but not least, I got what's ever left there. All right. So here we go. K squared minus 2k squared is 6k squared. And negative k minus 5k is negative 6k. Be careful of that to include that negative 1 in front there, right? And then lastly, I get a plus 7. And then this problem is done. There's nothing more to do, right? I'm not going to put two things into the same group here, and that's an important thing. Okay, we're not going to try to combine stuff because we need to remember that k squareds are k squareds, which are separate from k's. So we're going to also take a look at now at number 14, right? And one of the things I want to talk about 14 is that there's some x squareds, right? So we've already got that kind of written down. Okay, x squareds are equal to x squareds, right? And reflexive property, y squareds are y squareds, all right? So I'll write them the same. And then we have this thing of xy, okay, which is important because an xy is equal to an xy. It's xy's are not equal to x's. They're not equal to just y's. And xy must be paired with another xy. That's the importance of this idea of the reflexive property. It allows us to determine what things are what they say they are. So if I say it's an xy, okay, you must pair it with another xy specifically. So in number 14, the only two things here that are actually the same, even though we've got a bunch of x's and y's floating around, is that the positive 2xy can only be paired with the negative 7xy. So doing the math with the coefficient, that's what we do the math with, we end up with this negative 5xy. Well, the x squared couldn't combine with anything. So, right, x squared, the things in blue become a negative 5 because 2 minus 7 is negative 5. Just make sure you match it up with an xy with it. And then write plus this 4y squared, which had no partners. And then that problem is done. It's finito. Okay, so number 14 is very similar to problem 15 in here, and number 12 is very similar to 16. So if you want to get some practice in there or on the screen, pause the video and do these problems. The next thing we're going to look at is geometric applications. Geometric applications with this, right? Geometric applications is pretty much all we can do here is perimeter. All right, so here's some things that your teacher may give to you, or if you're watching this from my class, obviously you're going to be getting these problems. So perimeter. Perimeter is the sum, okay, of all exterior sides. Okay, so the sum of all exterior sides. So basically you need to add up all the sides that make the shape. So I'm going to do one of these, and then you pretty much get the gist for the rest of them. So 17, what I'm looking to do is I'm looking to add all the sides together. So I get 2x plus 1 plus x plus 3x. I'm going to write, you can write it out if you want. If you want to do mental math within the problem, you can do that, right? If you know you're adding all the sides together, you kind of can look at this and go, okay, I'm going to do some combining of like terms. And when you combine like terms, right? When you combine like terms, you can only combine things that are the same. So I start off with some x's there. Well, does the other side have some x's? You betcha, it's got one of them. Well, does the next side have some x's? Yep, it's got three of them. So 2 plus 1 plus 3 makes 6. So I have a grand total of 6 x's. Just don't forget, if you're doing it from within the shape, don't forget this, oops, wrong thing there. Just don't forget this ranger, this lone constant here, which is a plus 1. And then this problem's done. That's it. So there's my final answer for this problem. It's 6x plus 1. And that's how you do the geometric problems where it says find a perimeter. Okay, we're not on area because area is multiplication. So for this video, we're really strictly covering additions and subtractions. All right, so now we're going to get into multiplication. So the multiplication we're going to specifically get into is what is called the distributive property. Okay, now the distributive property allows you to take a value, okay, that is outside of a parenthesis, and if it's multiplying a group, it's a property we follow, and it's a pretty simple one. Basically, what you're going to do is you're going to take the multiplier and you multiply it by each member of the group. Okay, the way you would say that mathematically is you would say I would multiply each term within the expression. So in this problem, what I'm going to take a look at, I'm going to do one or two of these, right? This should be review. If you're, in an Algebra 1 class at this point, but I'm going to review it. I'm going to pick a couple just to go through and review, and then we'll go from there. So one of the ones I'm definitely going to do is I'm going to do number 2, I'm going to do number 5, I'm going to do number 7, and then we'll take a look at also doing number 15 down here. So I'll do not number 15, I'll do number 14 here, right? So I'll do number 14. Okay, so now multiplication is not the same as additions and subtractions, right? Addition and subtractions, you can only combine things together that are alike, okay? Well, multiplication is what enables us to combine unlike things. So multiplication allows me to bring together an x and a y. Okay, multiplication allows me to bring together a number and a variable. So that's important. So multiplication allows me to bring together unlikes, whereas addition and subtraction does not. So it's a distinction you want to have, okay? So at the end of this, we're going to do some distribute and then combining, and then that's how we're going to end this video out. All right, so number 2. So number 2 in this problem says the distributive property. So we're doing 2 times the quantity. Okay, we call a expression in parentheses a quantity. So 2 times the quantity of b minus 3. The way that this property works is you take the 2, you multiply it by b, and 2 times b is simply written as 2b. And then I will take that 2, and it has to multiply every member of the group. So the second member of the group is negative 3, so I must recycle that 2 and do 2 times negative 3, which gets negative 6. So the final answer is 2b minus 6, and it's done. Now, in number 5, recall we've talked about this in my class a lot, and I don't know if you've talked about this with your teachers if you're not watching this from outside my class, but you do need to know that negative in front of any algebraic symbol, it doesn't matter whether it's a variable, it doesn't matter if it's a parenthesis, if you put a negative in front of a algebraic symbol, no matter what it is, could be a number, could be a variable, could be a grouping, whatever it may be, you need to know that that represents negative 1 times that algebraic symbol. So in this problem, I'm not distributing a negative, I am multiplying by negative 1. So this problem can really be thought of as negative 1 times y minus 9. So I'm going to go through the problem. Negative 1 times y, and negative 1 times y is written as negative y. And negative times a negative, be very cognizant here of what you're writing. So the negative times the negative will dictate the sign that I write, and the sign that I write is plus, because negative and negative make a positive, and 1 and 9 make positive 9 when multiplied together. And there you have it, negative y plus 9. Number 7, okay? So number 7 here says this negative 4, okay, this negative 4 times the quantity of negative w minus 10. So I must take this negative 4, multiply it by negative w, and when you do 2 negatives, you need to remember it makes a positive. So this becomes 4w. And then when I recycle that -4 to multiply the other member of the group, which is the -10, so a negative times a negative means I write a positive, okay? And when you multiply within groups, okay, don't just drop down the signs that separate the two things in the group. The sign that you get after a problem is the sign that the multiplication creates. So the sign created here is negative times a negative, which means we're writing a positive. So in fact, we get positive 40, and then the problem's done. On to 14, right? So in 14, so again, it doesn't matter if there's two terms in the group, and in this case, it doesn't matter if there's three terms in the group, right? So looking at this problem, right, it follows the same process. The multiplier must multiply each member of the group you are multiplying. So 2 must multiply x, and you get 2x. 2 must multiply -y, which is -2y. And 2 must multiply +8, which is +16. And then at that point, it's done. It's finished, okay? Now, one thing that I haven't got into yet that I'm going to get into is doing number 13. And the reason I want to do number 13 is because notice number 13 is a little bit different than the rest. The multiplier involves a variable. And that's what I'm going to talk about from the standpoint of before. The nice thing about multiplication allows you to bring together unlike terms. So when multiplying, you can put them together, but when adding and subtracting, you cannot. So that's a distinction that needs to be made. All right, so multiplying 6a times b is just, well, 6ab. You mash them together. And then I take that 6a and I multiply it by the 2c. Well, 6 times 2 makes +12. And then I mash together the variables to make an AC. And then the problem's done. That's it. Okay. If you're looking for some practice here, there's some ones with fractions. I'm not going to get into those right now for this video, but they're done the same exact way, whether they're a fraction or not. Okay, the fraction, you would just be multiplying the entire fraction into the problem. So 1/4 times 8, and then you would do 1/4 times -4. Okay. All right, and if you need a calculator to do that, by all means, go ahead. I would stress not using a calculator because, again, a calculator should not replace a skill that you can't do. So if you can't do that without a calculator, make sure you can do that without a calculator, and then you can use a calculator to make the skill go faster. All right, so last thing we're going to do is we're going to combine the two elements of this video into one, which means we're going to combine the distributive property with, well, what happens after the distributive property if I have some terms that are alike, what can I do, right? So that's what we're going to talk about, and I'm going to do the odds in this video, or I'm going to do the first two, I should say. Okay, I'm going to do 19 and 20. If you can do 19 and 20, you pretty much can do the rest of these. It's just a little bit more work. So here we go. All right, so first things first, we're going to look at the distributive property. In this problem, we're going to follow PEMDAS, okay? So I write PEMDAS like this. So following PEMDAS, we need to recognize that the distributive property, okay, is a property of multiplication. So we must do multiplication before we start adding things together. So the first thing I'm going to do is take that 8 and distribute it into both things. So 8 times 2x is 16x, and then 8 times -3 is -24. And then I'm just going to write this -6x, right? We're not multiplying 8 into the -6x because the parenthesis closes, which means the -6x is not part of the group. So don't be multiplying everything like there's, no rhyme or reason to it, right? We're only multiplying what's within the grouping symbols. So now I take a look at this and I go, okay, well, is there anything that is a remaining thing that is similar or looks the same? And remember, we talked about how all x's are the same x. So those x's and those x's are the same. So using the coefficients to do the math, 16 minus 6 is 10. So I have 10 x's. The 24 doesn't have anything, so it's just -24. And then this problem's done. So moving on to the next one, which is number 20, same deal. I've got a 9 out in front of a parenthesis, and over here I've got a -2. Be very, very, to be very, very clear about this, it's not just a 2, right? That is a -2. Very, very important to pick up those signs, okay? Biggest mistake mathematicians make is they forget those signs. Don't forget them. You'll do a much better job. All right, so here we go. 9 times 2k is going to be 18k. 9 times -4 is -36. Flipping over to the second multiplication in PEMDAS, -2 times 7 is -14k. And -2 times -12 is positive 24. So now we're going to take a look at this and start looking at some combining of like terms. So K's are all the same. So K is a K no matter where you place it. So I now can do the math with the numbers in front. So 18 minus 14 is going to be 4K. Constants are the same as all other constants, so I can add them up. So -36, okay, plus 24 is -12. And then the problem's done, okay? Variable terms cannot be combined with constant terms. So I get 4k minus 12. And now I'm going to do one more in this video because I want to point out some important things here, but I'm going to do number 22 here. And what I want to point out in number 22 here very specifically is when I take a look at this, it says 6 plus 8 here. And it's very, very common that people like to read 6 plus 8, and your intuition is to do 6 plus 8 and write 14. And the problem with that is that you immediately break, okay, the rules of PEMDAS. And PEMDAS are multiplications must occur before you start trying to add things together. So with that being stated, it's very, very, very important that you recognize that a number next to a parenthesis represents multiplication. So before you get to be combining that 6 and that 8, okay, you got to do the multiplication with the 8 because that 8 is a distributive property. So that positive 8 doesn't mean plus 8 here. It means positive 8 times 4W. Positive 8 times -7, okay? So this positive 8 does not mean plus 8 in this problem. It means positive 8 times because of that parenthesis behind it. So that's an important feature that we got to pick up when we're doing these problems. So 6, and then we do positive 8 times 4. So this 6 is nothing to be done with. So I'm just going to write it down below. And now I'm going to write positive 8 times 4W, which gets me positive 32W. And positive 8 times -7 gets me that -56. And then creeping on behind it here, okay, creeping along here through this problem, remember that's a minus sign. And when you put a minus sign in front of any algebraic symbol, it really means -1. Okay, -1 times that symbol. So I now have to do -1 here, okay, times 2W, which is -2W. And -1 times +1, well, negative times a positive is a negative. So I get -1. Now, at this point, we look at utilizing the reflexive property, which states that a number is always itself or a variable is always itself. So in this case, I notice that I have a W, so all W's are the same thing. So this W and this W have to be the same because once you call it W, it's always W. So we can do the math with the number in front. So positive 32 minus 2 is 30. And that reflects the amount of W's that were in this problem. And then the last thing I get to do is I get to take the positive 6, the negative 56, and the -1 and sum those together. So 6 minus 56 minus 1 is -51. And then that problem is done. So then that also concludes the end of this video. So if you liked it, give it a thumbs up. It lets me know if the explanations I'm giving you are helping. So thanks and have a good one.